This is problem 36 in chapter 7, and it talks about power. Power is the amount of work done over time. So the units are watts, which are work in joules, divided by time, which is in seconds. So a joule per second is a watt. So a person does 6 million joules of work. And that's of useful work, in 8 hours. And the question is, what's the power, average useful power of that person? So the power equals the watts of the work done by a person over a period of time, 6 times 10 to the 6 joules, divided by 8 hours, but we have to convert to seconds. So that's 3,600 seconds, 60 minutes times 60 seconds per hour. When you calculate this out, you get about 208 watts. So that person's working pretty darn hard. Then the question is, how much time does it take for that person working at that rate to lift 2,000 kilograms of bricks up 1.5 meters? So in this situation, the work that's done is equal to mgh. So that's 2,000 kilograms times 9.8 meters per second squared times 1.5 meters. So the work that's needed to be done is 2.81 times 10 to the 6 joules. We got to be really careful here because we got W's all over the place. Up here we're figuring out the power. That is the unit of watts, that W there. Over here we're talking about work needed to raise 2,000 kilograms of bricks up to a distance of 1.5 meters. So this W here is work, and its units are transferring energy, so its units are joules. Up here that's 208 watts, which is joules per second. So if we want to find out how much time it takes, then we just take the amount of work done divided by the power. So that's 2.81 times 10 to the 6 joules divided by 208 watts, and that gives about 141 seconds. So several minutes.